All right, so number 6, Alexis has a basketball autographed by LeBron James. She wants to mail to her nephew as a birthday gift. The basketball has a diameter of 10 inches. So if we have a basketball, the diameter is 10 inches. She wants it to fit snugly into a box, so it's going to fit perfectly into this box all the way around without extra bouncy space. What is the volume of the sphere? So first of all, I have a diameter of 10. Diameter does not matter, so we want to have radius of 5. And remember, this is pi r cubed times 4 divided by 3 for sphere. So we're going to do 4, and we'll use 3.14 again, times 5 cubed, all divided by 3. So that's 3.14 times 4, and then cube that 5, which means 5 times 5 times 5. And then we're going to divide that by 3. So it's going to be 523.3 repeating inches cubed for your sphere. So what's the smallest volume of the box? So for this sphere to fit snugly, it would be 10 by 10 by 10, because the full length. So it would be front to back box, side to side box. So 10 times 10 would be 100, times 10 would be 1,000. So the volume of the box is going to be 1,000 inches cubed. What is the volume of the unfilled space? So we're talking about like this, that air space where you might want to put pop in or the styrofoam stuff to make sure it's not going to move around even more if you needed to. If you were packing something breakable, you'd want to put things in that space. So then we're going to take the difference in these two. So 10,000 minus 523.33 repeating. And you can go 3 spaces out if you wanted. But the idea is to be generally in the right vicinity. So the free space is 476.67. So if that free space could have been reshaped, we could almost fit another basketball in there. So this would be our free space. So again, because it's going to fit snugly, the side, like the width and the length back and the height of your box needs to be the same length as the diameter. All right, so number 7, Stephen wants to fill a circular wading pool. So circular pool. It has a diameter of 100 centimeters, which means our radius is going to be 50, and the depth is 20. What is the volume of the pool? So again, this is your 3.14 times our 50 squared times our height. So 50 squared times 20, and you can do it in any order you want, times 3.14. Looks like our volume is going to be pretty large, and that is going to be centimeters cubed, so 157,000 centimeters cubed. If you wanted to leave a 5 centimeter lip so the pool doesn't overflow when you jump in, what volume of water would need to fill the pool? So instead of filling it all the way to the 20, we're going to use a 15. So 3.14 times 50 squared times the height, which will be 15, because that will give us that lip, an extra space when you go to jump in that pool to make sure it doesn't overflow. And that means I just want 117,750 centimeters worth of volume water in the pool. Now, Sam is going to help Steve to fill up his pool. He's going to use a rectangular pail. So you want to think about a rectangular pail. So we're looking at a bucket that looks like it's a square or a cube, but it's rectangular. So the dimensions of the pail are 15 by 12 by 10. Assume Sam can fill the pail to the brim. How many pails will it take to fill the pool? So I need to know the volume of this pail if I can fill it all the way to the brim. So 15 times 12 times 10. So if I fill it all the way to the top, and he's magical, he can walk without spilling it, I can fit this much into the pail. But to fill the pool all the way to the top, so we'll go all the way to the top, the 15. So I need how many times this will go into the 157,000. So 157,000 divided by 1,800. So obviously we're not jumping in that pool, and we can magically make that bucket not spill. So it's going to take 87.22 pails. So it's going to take you more than 87 pails to fill the pool. All right, guys, word problems, study them. Text me if you have questions.